to my channel TM Tech. So today is all about operating system part 7. So today's concept is about kernel. Here guys, don't be afraid of this much matter. I'll explain you in a short way that you'll understand in a very quick manner. So firstly, let's know about what is a kernel. Here, the kernel is nothing about the core part of an operating system. Here, this kernel acts as a bridge between hardware and software. Without this kernel, your computer programs cannot talk to the hardware like CPU, RAM. RAM is nothing but random access memory, which is disk, keyboard, etc. Here, it manages everything happens inside the computer. For example, think of the kernel as a traffic controller. It makes sure all programs and hardware resources work together smoothly without any crashing or without any accident. So this is all about kernel. So this matter is you have to just need to understand. It will be so easy. You just note down this all matter. So coming to next one, which is features of kernel. Here there are 4 features. First one, let's go into it. First one, which is access computer resource. First, let's talk about the definition. A kernel access various computer resources like the CPU, input devices, output devices, and other resources. Kernel is present in between the user and the resources of the system to establish the communication. Here, it is saying about kernel, which helps programs, uses the CPU, memory, input and output devices like keyboard, printer, mouse, etc. It works as a middleman between you, that means the user. Here the user is nothing but the person who is controlling or handling the computer. And it works as a middleman between you, that means the user, and the computer hardware. Now coming to the resource management. Here, kernel shares the resource between various processes in a way that there is uniform access to the resources by every process. Here, resource management is nothing but which kernel shares resources, CPU time, memory, devices between different programs. Here, it makes very sure every program gets a fair chance to use the resources. That means if I am doing here screen recording or running another programs like PowerPoint or recording a screen or listening to a songs or even downloading something, this resource management gives every app a fair chance to use the resources. Yeah. Now coming to another resource, which is memory management. Here, firstly, let's discuss about the definition. Generally, memory management is done by the kernel because every process needs some memory space and memory has to be allocated and reallocated for its execution. It is nothing but every program needs some memory to run, which is random access memory, for example. Here, the kernel gives memory to each program when it's needed and takes it back when the program is finished. For example, when you open the Chrome, the kernel gives it a RAM. When you choose Chrome, the kernel frees the RAM. Okay, here RAM is nothing but random access memory. Now coming to the device management, the allocation of the peripheral devices connected in the system used by the process is managed by the kernel. Here, this is nothing but the kernel controls all the devices connected to the computer, like keyboard, mouse, printer, USB, etc. It decides which program can use which device and when. For example, if 2 apps want to use the printer, the kernel manages the order so they don't clash. In short, the kernel manages memory for programs and kernel controls devices so everything runs smoothly. Now, coming to another topic, which is types of kernel. Actually, there are 3 types of kernel. I have just mentioned 2 here. First one is all about monolithic kernels and second one is microkernels, and third one is all about hybrid kernels. First, let us discuss about monolithic kernels. Here in monolithic kernels, Here in monolithic kernels, in all services like users and kernel services run in the same memory space. This makes execution faster because there is no switching between user space and kernel space. But since everything is in one big block, the kernel sizes large and a small bug can crash the whole system. For example, imagine a restaurant kitchen where all chefs works in the same room with no separation. Food comes out faster, right? But if one chef messes up badly, here, but if one chef messes up badly, that means here a bug. The whole kitchen is affected with the system crash, right? In short, monolithic kernel is fast, powerful, but risky in errors. If errors happen. Now, coming to the next one, which is microkernel. Here, microkernel, in a short way, in a microkernel, user services and kernel services are kept in the separate spaces. For example, user space and kernel space. This makes the kernel smaller and more secure. But communication between spaces is slower compared to the monolithic kernel. For example, Mac OS, QNX, and Linux uses microkernels. In short, microkernels is equals to smaller, safer, stable, and slower than monolithic kernels. Now coming to our last topic, which is hybrid kernels. So this matter is all about microkernels. Here, as we are using different spaces for user and service kernel services, the communication between application and services is done with the help of message parsing because of this. It reduces the speed of execution, as I have told you. It is smaller, safer, but stable, but slower than monolithic kernel. Here these all have disadvantages in them. Now coming to our hybrid kernel, it is a combination of monolithic kernel and microkernel. It uses the speed of monolithic kernel and the modularity of microkernel. Hybrid kernels are microkernels having some non-essential codes in kernel space. In order for the code to run more quickly than it would be user space. So, some services like network stack or file systems are run in the kernel space to reduce the performance overhead. But still, it runs kernel code as servers in the user space. So guys, here it is not needed to afraid that I'm giving much matter, but let me explain you in a short way for a hybrid kernel. A hybrid kernel is a mix of monolithic kernel plus microkernel that I have told you in this. See here, I'm showing enough arrow for you. So it keeps the speed of the monolithic kernel and the modularity of a microkernel. So it keeps the speed of monolithic kernel like many services together and the safety of microkernels, some services separated. But here which is it balanced both, not too big, not too small. For example, in real life example, let me explain in a simple way. Think of a restaurant, okay, where chefs share one big kitchen which is fast like monolithic. But in some critical sections, like desserts or VIP orders, are kept in a separate rooms for safety like microkernels. In both, hybrid kernel is fast plus secure. Best of both works. Now you'll have all three types clear, right? Firstly, monolithic kernels, which is fast, big, risky like the OSs like Linux and MS-DOS. And microkernel is equals to small, safe but slower, which is Mac OS, QNX, and Linux. And now hybrid, mix of both fast plus safe, Windows of Mac OS and X. So this is all about our today's session. If you want these videos in Telugu or Hindi, please do comment down in this comment section below. We'll provide you all the links of these. And please do like, share, subscribe to our channel that all the programmers can be stable in it. Thank you guys. Meet you in the next video. Bye.